If you haven't checked out the art gallery, we have some incredible artists with a theme hero versus villain. So go check that out if you haven't already. Next up, we have Mehdi Ashraphijuo and Ramtin Madani from NoFeeSwap, and they're going to be talking about NoFeeSwap, a zero-spread automated market-making protocol, Part 2, features.
Thank you. All right. Hello, everyone. Thank you for joining us. My name is Ramtin Madani. In this presentation, we are going to introduce some of the unique features of the NoFeeSwap protocol. We shared our code base with the community earlier this week for the first time after our security audits. First, we provide a summary of the features. Then we'll go over more explanations on each item. We are first going to talk about customization within concentrated liquidity intervals. We want to do it in a way that LP growth and security would be guaranteed. Let's talk about the existing platforms first. In a Uniswap v3 pool, these liquidity distributions are all you get. Either half of every liquidity interval is empty, which is not efficient, or all of it is empty, which is not an AMM anymore, just two constant prices. One price is for buying, and the other price is for selling. With Uniswap v4, you can move around the fee. Basically, fee is a big trade-off between LP's profit per trade and volume. And you can also rely on hooks with custom curves. But there is an issue of security, there is an issue of solvency. Basically, in Uniswap v4, the security of custom curves is outsourced to hooks. And we don't know what is going to happen if something goes wrong with those hooks. Hopefully, they won't throw hook developers under the bus. Because, as we'll demonstrate later in this presentation, it is not as straightforward to design a secure custom curve. What NoFeeSwap offers is full flexibility and, at the same time, an underlying mathematical foundation is present at protocol level that guarantees LP growth and security. Here is an example of a simple formula one can use for liquidity provision in each interval of NoFeeSwap. And NoFeeSwap has great emphasis on security. This is because the design of a custom curve is difficult. Say you want to improve the XY equal to 1 formula using a hook in Uniswap v4. You may want to do that using an alternative formula. You may want to do that using dynamic fees or moving around liquidity via hooks, or even building your own custom accounting from scratch. There is a lot of issues that may arise. For instance, the price should be respected in transition from a curve to another. And this can be very easily mishandled. Here, as you can see, a sequence of swaps has bypassed the pool's logic. If a slippage is not enforced aggressively enough, we encounter the same issue, because the new curve is underneath the old one. And if a slippage is too much, we are basically wasting liquidity. NoFeeSwap handles all of these security concerns for you on-chain. Next, I'm going to talk about zero spread. One major benefit of this zero spread framework is that you get a lot more trade activity within the highlighted region. And the pools have pinpoint price accuracy. pools can do all sorts of optimization using arbitrary liquidity distribution functions. They will not lose volume or price staleness or even security concerns. Another major drawback up there is the absence of compounding. The collected fees are not added back to the liquidity pool, but NoFeeSwap offers compound growth for liquidity providers. Another feature is that trades are not limited to native and ERC20 tokens. You can even swap multi-tokens. One cool thing is that you can trade NoFeeSwap liquidity positions as well. Next, we're going to briefly mention the NoFeeSwap operator contract. With the conventional slippage control mechanisms, this is all you get. The outgoing and incoming amounts are compared against given thresholds. And it doesn't fully mitigate consensus layer risks. It just reduces them. With NoFeeSwap, the operator contract, you can program your own method of slippage control, or rather, you can easily incorporate any logic. It is like the EVM itself. Next, I'm going to talk about hooks. The yellow paper explains how NoFeeSwap hooks operate. For example, the hooks do not need to access pool data externally. It is offered to them for free. There are a number of singleton features as well. For instance, NoFeeSwap allows you to handle EVM storage more efficiently because you can incorporate multiple balances into a single storage slot. There's also an incentive program in place through which the pools of the 6 pairs can be rewarded with NoFeeSwap governance tokens. We consider adding additional pairs as well. Please see the yellow paper for more details. There's a vault for NoFeeSwap governance tokens in which you can deposit your tokens to be rewarded with more tokens. Additionally, while depositing, you do not lose the ability to vote. You can still delegate your voting power to yourself or any other wallet. There are many other features and tools. For example, say you want to deposit liquidity in a stable pool, where the price is always around 1. Consider Uniswap v3 or v4. The tick that corresponds to price equal to 1 can be constantly touched by swappers because there is no offset. And this is another source of inefficiency. The way this is handled in NoFeeSwap is through a price offset. Another cool feature is the ability to modify liquidity distribution dynamically if appropriate permission flags are set. We will also cover additional new tools for arbitrageurs. The project introduces tons of new EVM-based math functions for devs to look at. The purpose was to develop tailored functions with the highest level of gas efficiency. Let me go over a couple of examples. There is this chip muldiv function that comes pretty handy with minimal gas. And there is a very precise exponential function that the protocol uses.
So in the remainder of this presentation, we elaborate a bit more on some of the features that we just introduced. So the first feature that we are going to discuss more is customization within concentrated liquidity intervals. To this end, we need to briefly cover conventional AMMs. Most of you are probably familiar with the well-known AMM formula xy equal to 1. There are other variants of this formula, such as the ones adopted by the Curve protocol, such as xy plus x plus y equal to 3, or the balancer formula. The main idea behind NoFeeSwap is to allow you to choose your own arbitrary curve. And it can be anything. It doesn't even have to be a closed form algebraic expression like the above ones. NoFeeSwap is basically a safe and fair AMM environment for people to create their own custom curves. And they can make it as customized as they want, as long as it's safe and it can be incorporated, into Uniswap. Conventional protocols make money by imposing a fee. The fee can be interpreted as a liquidity gap, or it can be seen as a bent curve. As you see here, the curve is not smooth. It is, in fact, pointed. The left boundary is the buy price, and the right boundary is the sell price. In NoFeeSwap, pools can adopt a kernel function which determines how aggressively they want to charge slippage at each price point. It can be as sci-fi as you want, like this figure. Or it can be something simple. Based on the given kernel functions, your curves are then constructed on top of each other according to a set of formulas. After each swap, a new curve is generated on top of the old one. These are smooth and differentiable curves that are tangent to each other with zero buy-sell spread, like layers of onion. And that's how liquidity keeps growing. We go from a lower point to a higher point. Next, we are going to talk about the zero spread feature. Here is Uniswap v3 as described before. NoFeeSwap is all about eliminating the liquidity gaps that you see in conventional dexes, which is even more problematic for stablecoins. As you can see here, we see a much wider liquidity gap. Now, as an interesting thing about NoFeeSwap is that it allows you to close this gap however you want and still make money for LPs. There is no price staleness, and there is liquidity available at every price, which leads to higher volume. You can make it look like this. You can make it look like that, as customized as you want. Next, we are going to talk about how concentrated liquidity is handled by NoFeeSwap. In every NoFeeSwap liquidity pool, the logarithmic price horizon is divided into a sequence of intervals. You can set whatever offset you like for the price. The LPs have the option to deposit their liquidity in any continuous range of their choosing. They receive shares, and these shares become more and more valuable with swaps. We keep track of this via a parameter which is called growth. In other words, when a liquidity interval is touched via either a swap or donate, the amount of liquidity in that interval grows with compounding. Upon initialization, the pool owner provides a kernel function, and the liquidity in each interval is distributed based on this function. It can even change dynamically if a permission flag in pool ID is set. Next, we are going to talk about tags. Every token or multi-token asset which may be traded on NoFeeSwap Singleton is assigned a tag. A tag may refer to any of the following on-chain assets. It may correspond to native tokens. It may correspond to ERC20 fungible tokens. Tags may even refer to multi-tokens. And they can also refer to NoFeeSwap's liquidity positions. All of these assets can be traded on NoFeeSwap. We're going to talk about the operator contract next. We want to offer most flexibility to people so that they can implement and pay for whatever slippage checks that they deem necessary. This is why the slippage checks is not hard-coded like other platforms. For instance, you can invoke NoFeeSwap unlock method from your wallet. The operator contract is then invoked by Core. And then the operator takes care of everything on your behalf. The next feature that I would like to cover concerns hooks and permissions. Pools have the option to subscribe to a hook contract of their choosing. There are 17 permission flags for each hook. And when a hook is invoked, an entire snapshot of memory is given to the hook as call data. And all of the pool parameters can be accessed using a dedicated library that can be used by hooks. At least one of the initialized hooks needs to be activated upon the a pool initialization. And there are 3 hooks associated with depositing liquidity. 3 hooks associated with withdrawing liquidity. 3 hooks associated with swaps. 3 hooks associated with donations to the active liquidity intervals. And you can invoke hooks upon kernel modifications, which modifies the distribution of liquidity. There is a permission flag which determines whether kernels can ever be modified. As a pool owner, you may be rewarded with a portion of the pool's liquidity growth. This has to be permitted by the protocol. And there is a flag which determines whether the portion can ever be updated. Lastly, there is a flag which determines whether donations are allowed. Next, we are going to cover some of the singleton features. To further reduce gas cost, the singleton can be used instead of wallets. We are also allowing accounts to store multiple balances in one storage slot to further save gas. You can transfer money from your wallet to the singleton contract and receive multi-token credit. And these balances are much cheaper to interact with. We also allow accounts to store 2 balances in one storage slot to further save gas. When executing a complicated swap router, it doesn't matter how many pools you are interacting with. When you interact with a pool, the outgoing and incoming amounts are credited to the singleton's transient storage, and you decide on how you want to pay them. More about the additional features that NoFeeSwap introduces. Let's say you want to do a swap. This is the interface that you would be dealing with. You need to specify the pool ID. You can specify your outgoing amount or incoming amount. And this would be a constraint imposed on your swap. So the traded amount will not go beyond this value. You can also completely relax this requirement by setting a plus or minus infinity. This parameter is the maximum logarithmic price limit that you as a swapper would be comfortable with. Swappers have the option to choose either direction via this 041 input, which is pretty standard, but note that the type here is an unsigned integer. This is because you can pass any arbitrary value greater than 1 to indicate that the direction is arbitrary. Arbitrary direction is particularly useful for advanced arbitrageurs that don't care about the direction and want the direction to be determined based on the log price limit. There is an optional hidden parameter called cross threshold, which is embedded as the most significant 128 bits of 041. The cross-threshold parameter can prevent the swap mechanism from entering low liquidity intervals. This is a standard hook data input as well, and the content will be relayed directly to the hook contract associated with it. And there's a standard hook data as well, which I mentioned. And lastly, the outgoing and incoming token amounts are returned as the output of the swap method. And so in summary, the essence of this protocol is to allow you to be as creative as you want with AMMs while protecting LPs. Please reach out to us and check out our GitHub repositories. We are now active on all social media, and we are looking forward to hearing from you, your insight and your ideas. If you're interested, there are tons of opportunities in our group. We are always welcoming fresh talents. Thank you very much.